Hello viewers, I am Mrs. Mercy Anthony, Assistant Professor and Head, Department of Statistics in St. Joseph's College of Arts and Science, Autonomous, Kadalur. Today I will talk on the topic hypothesis testing. Now what is hypothesis? Hypothesis is a predictive statement capable of being tested by scientific methods that relates an independent variables to some dependent variables. A hypothesis states what we are looking for, and it is a proportion which can be put to a test to determine its validity. Now this will be more clear by an example. If we take the example that countries with lockdown will have less corona patients than the countries without lockdown. Here in this example, we predict that the statement that the lockdown will decrease the spread of corona disease is a hypothesis. Now here we are given some of the characteristics of hypothesis. First is clear and precise, capable of being tested, stated relationship between variables, limited in scope and must be specific, stated as far as possible in most simple terms so that it is easily understood by all concerned. And the last one is consistent with most known facts. Now here we are having the hypothesis which is framed under two types. First is null hypothesis and second one is alternative hypothesis. Now what is null hypothesis? It is a statement that we hold as true unless we have sufficient statistical evidence to conclude otherwise. Now the null hypothesis is denoted by H naught. If the population mean is equal to hypothesized mean, then the null hypothesis can be written as H naught such that mu is equal to mu naught. Next is alternative hypothesis. The alternative hypothesis is opposite of the null hypothesis, which is denoted by H1. If null is given as H naught such that mu is equal to mu naught, then the alternative hypothesis can be written in these three states. First one is H1 such that mu not equal to mu naught. Now this is called two-tailed test. The second condition is H1 such that mu less than mu naught, that is called left-tailed test. And the third one is H1 such that mu greater than mu naught, that is called right-tailed test. Now some concept of hypothesis testing we will see here. The first one is the population. The population means that all possible values. Sample is a portion from the population. Statistical inference. It is generalizing from a sample to a population with calculated degree of certainty. The parameter. The parameter is a characteristics of population. For example, if we take the population mean, in parameter it is denoted as mu. Next is statistic. It is a calculated from data in the sample. For example, if we take the sample mean, it is denoted as x bar. Now this diagram shows what will go under the testing. First what we do is we'll take from the population a sample, and that sample goes to testing, that comes under data, and the next step is called statistic, and after the inference is that goes under the parameter. Next is level of significance and confidence interval. Significance means the percentage risk to reject a null hypothesis when it is true. It is denoted by alpha, generally taken as 1% and 5%. 1 minus alpha is the confidence interval in which the null hypothesis will exist when it is true. Now there are two types of errors. First one is type 1 and type 2 error. Now here what we do is, in this example, this is the situation and next is the decision. When the null hypothesis is true and our decision is we are accepting the null hypothesis, it is correct. But when the null hypothesis is true and our decision is we are rejecting the null hypothesis, then it becomes type 1 error. And type 1 error is denoted by alpha. Next is the situation where null hypothesis is false and our decision is we are rejecting the null hypothesis. That is, it is correct. But when the null hypothesis is false and we are accepting the null hypothesis, that becomes type 2 error, and that is denoted by beta. This will be more clear with this example. Suppose one topper student scores centum, it is correct. But if the topper student fails in the exam, that becomes type 1 error. And the next example is below average student. If a below average student scores centum, that becomes type 2 error. But that below average student, if he fails in the exam, that is correct statement. Now this graph shows the two-tailed test at 5% level of significance. The acceptance and rejection regions in case of two-tailed test. Now here is, if we are taking the null hypothesis as mu is equal to mu naught, the alternate becomes H1 such that mu not equal to mu naught. So this condition is known as two-tailed test. So here we are rejecting, this is rejection region and this is total acceptance region or confidence level, that is 1 minus alpha is equal to 95%. So here the 5%, so 5% means 5 is divided by 100, which will give 0.05. That comes for the one-tailed test. When it is two-tailed test, we again divide that value. So that is 0.05 is again divided by 2, which gives 0.025. So this is the two-tailed test significance level. Now this graph shows the region for one-tailed test, which is left-tailed test. So the graph here shows the rejection level. Next graph shows the rejection level and the acceptance level. So here it is H1 such that mu is greater than mu naught. Now next is the procedure for hypothesis testing. The first step is to state the null hypothesis and alternative hypothesis. This is the first step. Next step, what we do is we'll state a significance and we'll select the significance level, whether it is 1% or 5%. The next step is to decide a test, whether we have to, for example, whether we will go for T test, F test or Z test, etc. Next step is calculate the value of test statistics. And after we are calculating the test statistics, we'll calculate the p-value at given significance level from the table, and then we'll compare the p calculated value. And next is, if the p-value is greater than the calculated value, we'll accept the null hypothesis. If after comparing the p-value with the calculated value, if p-value is less than the calculated value, we'll reject the null hypothesis. Thank you for your attention. Hope you found this video useful and informative.